this video, we'll discuss proper use of our Bertec treadmill and Vicon Nexus software for motion capture data collection. The first step is to lock the treadmill by rotating the black handles on each side clockwise until you can't tighten them anymore. This will lock the treadmill in place in the Z direction. Please note that these should not be tightened until the treadmill has been adjusted to the desired incline for that trial. Adjusting the incline with these locks engaged can cause serious damage to the treadmill, so please double check that these are loosened before adjusting the incline and ask for help if needed. Next, turn on the treadmill by flipping the red switch on the front of the treadmill box. Note that it may take some time for the treadmill to start warming up and for the lights to turn on. In the meantime, use the two switches on the force plate box to turn it on. The treadmill is ready and powered once the emergency stop is flashing. Press the white Enable button and the treadmill is ready for data collection. Next, zero the force plates using the two red buttons on the front of the force plate box. Make sure that these are zeroed after you have locked the treadmill bars. Next, we can turn on the Vicon system using this switch located behind the treadmill box. Flick the switch to turn it into the on position. Now that everything's powered on, we can turn to the software. Open the Bertec treadmill software, which is denoted by the 3 red line logo. If the treadmill was powered up properly, you should see the words connected under treadmill controls, as well as force data streaming in the data view. You can play around with the different options to display different data depending on the type of data you're collecting. You can control the treadmill using these plus and minus buttons, or set a protocol to start once you hit the commit button. If you want to sync the 2 treadmill belts, click this lever. For data collection where you're syncing the treadmill with other software, use the remote control. Next, we'll open the Vicon software. Look for the Nexus logo and open the software. You should see the lockbox, which is next to the Vicon computer, start to light up. You can see the file structure here in the Nexus software. We have the database, which includes all the highest level folders for each researcher. A new folder can be created by clicking the green circle button and choosing a name for the folder. I'll name this one as example to show you here. If we open the folder, we then have the next layer where we can create folders for each specific study that we're doing. This folder will hold multiple sessions of data collection, and I'll create an example here called example again to show you. After this is created, we can move to the next type of folder, which is the lowest level and our individual sessions of data. In order to record data, you must be within a specific session folder. Press the Go Live button and you should see the cameras appear. Choose the X Forward 108 camera setup, as shown here. If you see red force arrows here, where no one is standing on the treadmill, this means that the zeroing of the plate hasn't been registered by Vicon. Re-click the red buttons to zero the force plates and you should see those arrows disappear. If there are any red or yellow boxes next to the cameras where you now see the green boxes, reach out to a PhD or other grad student for help troubleshooting camera connection and power issues. If the cameras in your 3D view don't look nice and ordered like this one but look scattered, don't worry, we're going to calibrate the cameras and fix that. Start by activating the video calibration. Then we will mask the cameras to have the cameras ignore any shiny object in the room that we don't want it to confuse as markers. The masking is done once you see all these white dots on the screen turn to a light blue color. Then you can stop the masking. Next, we will run the camera calibration. Make sure to use the advanced settings to change the wand counts for your desired application. For marker-based data collection, we tend to use higher values, so closer to around 10,000, whereas for markerless, we can use slightly less because we will not be calibrating the infrared cameras. Once we hit the Start button, under the calibration section, Turn on the red LED wand. Begin to wave it around the volume, above and around the treadmill, as shown here. Try to keep the wand flat and move it around in circular motions as if you're making pancakes on a pan. Watch the arrows in the corner of each camera screen. They should begin to turn green and then disappear. Once all the arrows have disappeared and all the physical camera lights have turned solid purple, the calibration will be done. Here is a sped up version of the progress of calibration over time. You can see the traces from the wand appear on the screen and the corner arrows turning to green and disappearing. It may take different amounts of time depending on how many wand frames you selected in the advanced settings. You'll see in the bottom right corner that the calibration starts being processed and the overall quality of the calibration is reported. You can look at both the world error and the wand count to see how well the cameras were able to calibrate. We want to see green boxes next to all of the cameras, indicating high quality calibration. If you see any yellow, orange, or red, please redo the calibration as this will have significant impact on the quality of your trial. Here you can see we can scroll down and we see all green boxes, so that means a successful calibration. We can stop the calibration. Next, we'll use the Set Volume Origin feature to set the location of the cameras. Place reflective markers at the points shown in these diagrams, balancing them on the head of the screws at these points along the treadmill. Once the markers have been placed, you can select the Set Volume Origin button. Once you click it, you should see the cameras pop into place, and these should align with what you see in the real lab environment. The video or Vicon cameras may turn red for a second and then will reload back to green. Remember to remove the reflective markers from the treadmill once you've completed the volume origin setting. You can also double check marker calibration by having someone step onto the treadmill. You should see their force vectors pop up here and see the marker appear in the space. You can check to make sure the marker appears consistently and solidly. Now we can switch over to the capture pane to begin collecting data for a trial. We'll start by choosing a name for the session. We can also choose which data sources we want to include, as well as any special settings for capturing the motion capture data. This includes setting how long the duration of the trial is, as well as special settings to connect it to external code. We can press the start button. Make sure you see the red flashing to indicate that recording is successfully running. Afterwards, we can open the trial. First, condense the video data by transferring it, by going to the transfer pane and clicking transfer video. You should see a yellow bar begin to run, indicating that the video is transferring. This will compress the files so that they take up less space on the Vicon computer. Transferring after every few trials is a good way to reduce the chance of frame drops happening. Once the file is transferred, we can open it up and see that now the video camera files have appeared. We can use the camera view to look and review the trial, noting that there was no subject here, so we don't see anything in the video pane. We can also look at other data using the graph function, such as force or other data that we collect from external devices. Thanks for watching. Please be sure to review our online manual as well, and don't be afraid to ask any questions if you're not sure how to operate something, to make sure that we can keep the system working well and remain safe while operating the treadmill and Vicon system.